Yes, so in this particular lecture, so we are going to write down the algorithm, along with we are going to understand the algorithm, along with we are going to write down the time complexity analysis, okay, of the problem that we have discussed in the previous lecture, that is parenthesis matching or matching parenthesis or balance parenthesis. If you have not watched the video related to the concept of balance parenthesis, just go to the previous video and watch that, and there I had given one particular assignment also. Try to solve that and come back. In this particular lecture, we will write down the complete algorithm. We will try to understand the time complexity of this particular algorithm. Okay, if you are new to this particular channel, just please subscribe and share with your friend, and don't forget to press the bell icon so that you will get a notification whenever I am making such kind of videos. Okay, so without further delay, so let's try to understand this particular algorithm. Okay, I think we have already discussed two three examples in the previous lecture. So this was a balance parenthesis, right? So just to recap, why it is a balance parenthesis, because if left parenthesis is coming, we'll push into the stack, then we'll scan, and there is a matching. So this is a matching, you can say, there is a matching. So if I'll put one more, so then there is a matching. If I put only one, that means single, so then there will be not matching, right? So that's what we need to implement. So let's try to write down the algorithm of this particular checking parenthesis. Okay, so this algorithm, just let's try to understand the concept. So this algorithm will take what input? Input, it is taking obviously a string, or you can say sequence of characters. So if we will treat this one as a character, sequence of character, or a character array, you can say. Okay, and what we are doing, we are scanning each and every element. That means we will write a for loop which will scan each and every element. So if left bracket will come, then we will push it into the stack, and if right bracket will come, then we will check whether a left bracket is present in the stack, then only we will extract it and tell that okay, it is matching, and we will continue that process. And if at last, if the stack is empty, then it is a balance parenthesis, otherwise not, right? So that's what the algorithm tells all about. Okay, so let's write down the algorithm. So I will start with here. Okay, so let me write down the algorithm. Okay, suppose parenthesis check. Okay, suppose parenthesis thesis check, any name you can give. So this is going to take what input? I'm just writing the algorithm. What input it is going to take? It is going to obviously take a character array, right? Character expression. Any name should be fine, but that should be character array. So that's what the algorithm started. Okay, so what I need to use, so this is the application of stack, right? So I'm going to use a stack, right? So I'm going to create a stack S. Okay, stack S. So I'm just writing the algorithm. So just stack S. If you are using Java, then you need to create using new operate, new Java, new stack. So that's fine. If you are using C, then you need to do in different way, but that's fine. You need to allocate the memory, but stack S is the stack. Suppose I am assuming that one is the stack. So what I need to do, I need to scan each and every element one by one. I need to scan this expression one by one, the element by element. Then if it is a left parenthesis, just push it into the stack. So that's what I need to do, right? So what I will do, then I will add a for loop here for expression, for I equal to 0, I less than expression dot length. I'm just writing this function, that's fine, I plus plus. So maybe it will be different for different languages, but that's fine. I'm just writing the algorithm. So you will check, so inside this for loop, so you will check if the given character is a left parenthesis or a right parenthesis, or what. If it is a left parenthesis, what we need to do, we need to push it into the stack. If it is a right parenthesis, then we need to pop some element and compare. So if, just check, if it is a left parenthesis, expression of I equal to a left parenthesis. Suppose this is the parenthesis. So what I will do, if I am checking if it is a left parenthesis, so then what I need to do, then you need to push that particular parenthesis. So s dot push this particular left parenthesis. Okay, you need to push this particular left parenthesis. That's what you need to do it, right? So you need to push it. So else, what else you need to do? You need to check if it is a right parenthesis, then you need to check for that, right? If it is left parenthesis, just push it. So that's all. Okay, that's all. So but if it is a, if you will check, if the same thing, expression of I is equal to right parenthesis. If it is a right parenthesis, can you tell me what we need to do? If it is a right parenthesis, what we need to do? We need to pop an element from the stack, and we will check whether they are matching with each other. That means whether the popped element is a left parenthesis or not. Okay. So before that, if a right parenthesis is coming, if think about that, a right parenthesis is coming, suppose initially a right parenthesis is coming, think about this situation, but there is no left parenthesis, you can immediately say that particular, this is a mismatch, right? So if you can check if the stack is empty or S is empty, you can write it down, or you can write a method S is empty or is empty. So if S is empty, so I am just writing it like this, S dot is empty or is empty, you are passing this. So then return false. What does that means? If stack is empty, a right parenthesis is coming, means there must be present a left parenthesis, but if no left parenthesis, then we need to return false, right? So then that is the situation. If that is not the case, that means something is there, then what you will do? You will check whether that is a left parenthesis, right? If you will pop the element from the stack S, if you will pop the element from the stack, and if it is equal to left parenthesis, then it is a matching, then you should be good. If it is a not matching, then you will check it. If it is a not matching, then return false. Okay, otherwise continue, you will just continue, because you are finding a matching, just continue. If you once you will get a mismatch, then just return false, you don't need to continue this for loop, right? So that's the logic. So once this is done, this for loop is done, once everything is done, stack should be empty. So that's what the condition. If the stack is empty, if is empty function is empty, stack S is empty, you can check. Stack we know, right? How can we check that stack is empty? If top equal to -1, okay, that's fine. If stack is empty, then we can say then print or system.out.println anything balance parenthesis. Given expression is balance parenthesis. Okay, that is this particular algorithm. Okay, so this is the algorithm, or maybe you can say coding. You can implement, you can convert this one into C language or Java language, any language. Most probably they will look similar in different languages, or C++ language or Python as well. So that's fine, but that's what this will look like. Okay, so this is how this particular algorithm or this particular scanning the or checking whether this particular given expression is having a balance parenthesis or not. Now the question comes, what is the time complexity of this particular algorithm? So if you see, we know that push and pop, all the operations are order of 1, right? So if you think about this one, this is order of 1, this is pushing also order of 1, this is also checking a single check, just a if condition, right? So this is order of 1. So if you think everything is in order of 1, so there is only a for loop, so here which is dominating, so this is going to be order of n. Then the total time complexity of this particular balance parenthesis is order of n. So that's the time complexity of this particular balance parenthesis problem. Okay guys, I think that's all for today. I hope you guys liked it, and in the next class we will be discussing different other applications of this stack. For then, goodbye, take care, and please subscribe and just press the bell icon. Thank you.